So we're back again. I see my audio is acting a little bit funny today, but I'll just hope it comes out okay on the recording. So we're back again, and as a reminder, if you go look at the YouTube video, if you look at the description down at the bottom, we've got links in there that one points to our index of this meeting and points to our composite index of what we've been doing for the last couple of years, I'll say last few years, because I've lost track of what we're doing. And it's also got a link to the original ROS agriculture stuff, the index I started on that. And there's I think a link to our YouTube video page and probably a link to the Slack channel. You may have to actually sign up for that to view it. I don't remember how any of that stuff works. And I keep saying I'm going to clean that up, but I haven't yet. So anyway, just if you're interested, you look at the description under this video, or if you go to the index file, it's got all the old indexes there. So you can from there, you can click on a thing and go right to a video and watch it if you find anything you like. So things I was pointing out. So a couple of weeks ago, I was saying that I was playing with my refrigerator stuff, and let's see, how can I do this? Share screen. And say desktop 1. And yeah, it looks like the right stuff's going out. So the plot at the top is what I was recording, and it was the blue line is the current for my AC power monitor, so you can see when the compressor's running, and then over here is when the doors open, and then over here the doors open, and this is probably some kind of a defrost cycle that's going on. And I was saying I thought it was odd that, you know, my temperature, the orange one is inside of my refrigerator and the yellow one's inside of my freezer. I thought it was odd that the temperature would change that much if the compressor was on or not. I couldn't figure that out. I was theorizing that if I'd tape a sensor to a thermal mass. So what I did, and of course it's not handy here. So what I did, I lost all my buttons here. How do I get back? How do I pause this? Okay, I'm not going to pause this. All my buttons have gone, and I don't know how to get them back. So on the top here, when I'd run it for a long period, this is like overnight or something, and you can see the compressor would run and then turn off and run and turn off. And while I was doing that, the temperature in the refrigerator would come up and down, and in the freezer would come up and down. So I said, well, let me take this green one, which is just an ambient temperature laying on the countertop, and I taped it to a pop can. It's actually like a sparkling water can or something. So it was a brand new can, and I taped the sensor to the side of that, and to get thermal contact with that. And then I thought, well, I should insulate, so I folded over a pot holder and taped that over the top. So basically, I've got one sensor is measuring the temperature of a fixed or a known quantity of water that's in the refrigerator, and then I've got another sensor just taped to the can, sticking up in the air so I can still get the air temperature. And the one in the freezer, again, is just stuck in there, so it's measuring air temperature. So the plot at the bottom, so again, the blue is the compressor turning on and off. And then the green is the temperature in the freezer going up and down, just the air temperature in the freezer. And then up here at the top, you can see the yellow one is the air temperature in the refrigerator. My scaling is kind of screwed here. I don't think I can rescale this. No, it's not going to rescale on the fly. So anyway, you can see the air temperature was basically following like it did on the top here. And then the orange one is the temperature of the pop can. So it's much more stable now as the thing runs. So I decided that yes, it's basically an optical illusion. You can see the air temperature in the refrigerator, but the stuff in the refrigerator, the food doesn't actually change temperature very quickly. So I decided I don't need to worry about that anymore. And it was just an experiment to see, you know, is that going to work? And I predicted what it's going to do, and it's not as flat as I expected, but it's also not varying up and down a lot like this one's doing. So I'm happier with that. And then my other problem was I was saying that I was reading both the AC power monitor and my temperature sensors with a Raspberry Pi. So I had Python code for both of those. And it turns out to read the temperature sensors, they take some amount of time to convert. And if you're running I looked it up, and if you're running a 12-bit conversion, which is the highest resolution you can get, it takes 750 milliseconds from the time you say start the reading until you can actually read the final value. And if you cut that down, if you cut it down to say 11 bits, then it drops by half down to like 375 milliseconds. If you drop down to 10 bits, it drops again to what 187 milliseconds. If you drop down to 9 bits, it gets down to like 87 milliseconds or something. So by adjusting the resolution, you can control how long it takes to run. But when I was looking at the Python code, I don't seem to have either it's not obvious or I don't have the option to make those work better. You basically you know kind of like a Linux thing, you take it or leave it. And I thought, well, I looked at the Arduino stuff and they seem to give you lots of different options, lots of different commands and ways to make all this stuff work. So I went out and just got a random Arduino, and first I loaded the so on my power monitor. Let's see if I stop sharing here. I think we're done with those pictures. So on the power monitor, view, speaker view. So on the power monitor, just that module, it's inside of a plastic box, and then this hooks up to the power. That big black thing is the transformer that reads the current. And now it's hooked up to an Arduino instead of a Raspberry Pi. And I just simply pulled up somebody's code. And if you're running an Arduino Nano or an Uno, it does not have an extra UART. So you can only you either have to use the USB or you can use the physical UART, but you can't use them at the same time. So they give you a code that says, here's how you do the software serial. And I loaded that up and that does seem to work. So I say, use the software serial to talk to the module, and then I can still get the data out the USB port. And that came up fairly easily, and it just simply reads the values and prints them on the screen. So I thought, well, that will work. I'm not going to figure out how to integrate the temperature sensors into that. So I pulled up code for that, and I ran through various examples. And yes, that does seem to run. And I think if I look at it hard enough, I can figure out how to say speed up the readings and keep everybody happy. So that I'm at the point I just need to integrate those together, and I think that will work. You know, get back to the point where I can do what I was doing before, but I'll have better control over what's happening. And then I can still plug the Arduino into a laptop or something and just fire up a serial terminal monitor and say log that. And so basically I can get the same kind of log files I was getting before, but I'm using it with an Arduino now. And at some point I was thinking, well, maybe I could get that to connect to my home network and get a server set up on a Raspberry Pi somewhere, something called Home Assistant and something called ESP32 Home. There's various projects out there that let you do that. So you create your own server. You don't have to go out to the cloud out on the internet to give them all your data, so you can actually keep everything on your own computer at home. And so that's something else. I'd have to dig into that to see what's going on there. And then somewhere along the line, I thought, well, maybe I want to be able to read wave things. So here I bought this load cell, and then the little green board is a load cell amplifier, and it hooks up to an Arduino. And I haven't actually run that because when I went and looked, so another tale. If you go out on YouTube and you're looking for projects, tutorials, and so forth, you know, you can sit down in the morning and say, I want to search for this load cell and the HX711 converter board, and it'll bring up all kinds of stuff. So you say bookmark this, bookmark this, bookmark this. So after you sat there all day, you got several pages of bookmarks. But the problem is, if you're not paying attention as you're going, you lose track of what is what, because once you say bookmark it, you lose the image that originally popped up on the screen, which enticed you to go watch it in the first place. And so now you have just this whole batch of things you have no idea what they are. So you have to click on them one at a time and look at it. And it turns out there's various qualities of presentation these people put out. A lot of it is just simply a duplicate. You get 10 or 20 different people who show you the exact same thing because they've copied somebody else that had done the exact same thing. And they seem to be fairly lax on documentation. So you'll pull one up and it says, but another thing that annoys me, I was going back and looking at them. So I pulled it up and say, here's a thumbnail. It shows a picture of one of these sensor modules. and then it showed like a Raspberry Pi or an Arduino Nano, and maybe an LCD display. And it the picture shows this type of LCD display with the 4-wire I2C interface, and it showed the picture showed an Arduino Nano, where you go watch the actual video. Well, they're using Arduino Uno, which isn't the end of the world, but still that wasn't in the picture, and they're using a display, either a 2-line or 4-line like this, with no adapter board on the back. So basically, the picture they show you does not match what they present in the thing you're looking for. So that adds to the complications on that. And then a lot of it is they'll say, "Oh, here, just put this code in." And sometimes they'll post the code. Sometimes you just have to see it on the screen. And then what was their problem with that? And then they'll say, "Oh, we're gonna put this example code in." And the top of the code says, "Oh, load this library to make it work." But they don't tell you where that library came from. And for this particular amplifier board, you go to the standard Arduino stuff, go to the library manager and say, "Show me the HX711," and there's like 10 or 20 different modules you could load, and it's not obvious which ones go with which device. So that adds to the complication. So I finally last night. Oh, so back to the original story. You sat there all day bookmarking all the stuff, and you come back the next day, and now YouTube starts throwing more stuff at you. So you go through and you double the number of bookmarks you have. So now you've made your mess even bigger, because you have no idea what any of that stuff is and if it was worth saving in the first place. So last night I sat down and said, "Okay, I'm going to go through and track this down." I tried going through, and I couldn't find anything that told me what I wanted. And then after a while, I just stumbled on one that this guy had done, and he did a pretty good job of everything. He said, "Oh, he got this sensor, and he said, I used this library," and he points to the actual GitHub for it, so you can see what the code was, and which one he had. And I think he can load that one directly through the Arduino library manager. So he's got a lot of stuff there. So I marked that one. So I started making subdirectories and said, "Okay, here's the stuff from this guy. Here's this video. Here's his GitHub." He has his own GitHub, and then he's got like a blog post or something. So he put all those pieces under the one thing. That makes it easier to find when you go back to find it. So I've yet to get this to run. And the other problem was, I thought, well, I'll use that LCD display, because originally somebody said, "Oh, here, use this Arduino Nano and this LCD display and this sensor." And when I went and looked at it, well, it didn't, the stuff didn't line up and didn't match. And I finally decided it'd be easier to just grab somebody's random example to make an Arduino talk to the sensor and be able to print out the weight, and then go back and start over and grab the LCD, hook it to an Arduino, and get the point. I can write to that, and then just merge those two together. So that's kind of where I'm at on that. It's just another thing that's going to waste my time, is basically what that's coming down to. So with all that stuff, I've got, as I say, I got the power monitor switched over, so it runs on an Arduino. I've got the Dallas temperature sensors, so they'll run on an Arduino. I want to merge those two together and then decide what to do with that. Either dump that out to a laptop to log it, or I could switch everything over to an ESP32 and then have it connect to my home network and send the data somewhere. So that's another whole journey to go down there. And then there's this weight sensor. Once I get it running, then I'll have to decide what I want to do with it. And when I started looking at these, it turns out these are really amazing. So I may think of something fun to do with it before I'm done here. So that's just more of my saga of trying to get temperatures and playing with my refrigerator and all that stuff. Basically, it all comes down to data logging. It's just a matter of trying to figure out different ways to data log. And if you're going to get, say, your home-based server where you can store this stuff, you can have little modules that say, like, have switch inputs that you can hook up to anything you want. You can have temperature inputs, you can have weight inputs. And so it's just a matter of then picking and choosing to say, I'm going to put a module in this room and hook these things up to it. And then in my kitchen, I might want to hook my refrigerator back up to it. And I might want to monitor my heating system. So all kinds of things you could do on that. So that's kind of where all that stuff's at. Oh, and another problem, when I decided I was going to switch over to the Arduino, I said, "Okay, I'll just pull up Arduino on this computer I'm using." And it turns out it's not on there. And that's my mainline computer that's hooked to my TV. So I watch all my YouTube and all my Amazon Prime movies and stuff on that. And there was no Arduino on that. So I thought it's probably on. So it's either on my computer that I'm using right now, the video computer for the meetings, or it's on my Windows computer. And I thought, well, since they announced that Windows 10 is now gone, I thought that this would be a good time to just stop and pull the hard drive out, put a new hard drive in, and put Linux on that. And that turned in somewhat of a journey. I was going to pull that up here. Let me see if I can just quickly grab that. So at one point I figured, as small as that computer is, it's what do they call it, a netbook. So it's one of the little small computers. And I thought, well, it's probably going to have an M.2 drive in the thing. It's probably not going to have a full size solid state drive in it. So I looked it up on the internet. It says, yep, it's just got a 2.5-inch solid state drive in there. So I popped it open, and much to my surprise, it's saying it has one of these, just a normal, flat 2.5-inch drive that fits in the thing, and it's got the standard interface on the thing there. When I popped it open, it had this in it, and this is basically so this thing is an adapter that fits down inside of where the normal drive would go, and it's screwed down, and it's got a little printed circuit board, and it's got an M.2 drive screwed down to that. See, is that obvious here? So anyway, this module right here is the hard drive, and it's screwed to an adapter board there. But then the connector out here is still the same. Still got the same standard interface. And this is an external USB to hard drive adapter. And it turns out if I pull this drive out and put a normal drive in its place, that does recognize that. I was able to load Linux on that. But if I take this drive and put it on this external adapter, it doesn't recognize that. For some reason, these two won't talk to each other, and I don't know why. So if I want the stuff off this, I'm probably gonna have to put this back in the computer and boot it up, and then dump everything I want onto another drive, and then go back and put put one of these kind of hard drives back in that's got the Linux loaded on the thing. So that's just another journey that's going to come up here. And I got as far as loading the Ubuntu 2404 onto that particular laptop, and that's all the farther I went with it, because I was pretty annoyed by that point. The fact I couldn't get anything to work, and whatever. So anyway, I still was sitting there with no Arduino IDE. And then a couple days later, I pulled up this computer I'm on right now, and sure enough, there's my IDE, and there's my code that I was playing with. So all my data logging code and everything's on there. So I was able to play with that and get it to do something, and that's kind of where that project sits. So if I get around to it, I'll do more data logging, I guess. The other thing was, several weeks ago, I was saying, boy, we were talking about the high power LEDs and the addressable LEDs. And I said, boy, it sure be handy if somebody actually made a high power LED that was the addressable stuff. So you just plug the thing in and it works. And I thought, yeah, that'd be great. And I thought, well, let me look for that. So I went to Amazon and started digging. And let me see if I can make this bigger. And I'm not sharing, so let me share this. And go to here. So let's see, it's going to pop up and tell me, yeah. So anyway, first of all, a word of caution. This board pops up and they want $100 for this board. Now, other people say that basically the same board for $10. So be careful. Again, be careful on Amazon, because they're gonna say, oh, here's this great board. It's got a high power LED on it, and it has the addressable input and output. And theoretically, this will do what you want, but remember, no matter what you look at, make sure, because it says $100.
It's $100.
It's $100.85. And I thought,
Holy
well,
crap.
well, obviously they're going to sell you more. But I read through the whole thing multiple times. This was like a week or two ago. I was doing this, and I can't find anything in there that says that it's more than a single board. So be real careful with all this stuff. And then the other thing was this one. So I think other than the fact they're screwing you on the price, it seems to do everything you need. This one is what, RGB addressable WS2811 IC. And here's another odd thing. It says 1.2 watts / 2.5 watts / 5 watts RGB. And then, you know, usually if they do that, then it'll be a thing down here. You can click on a thing and say, well, show me the small one, show the medium, show the large one, and they don't show you that anywhere. So that's another problem. That if you look at this picture, they show you 3 different sizes, but there's no way to order these different ones. So again, they want to charge you $100, and you might get this top one, or you don't. You might get the middle one. You don't know what you're going to get. So that's probably what they're talking about in the title. They have 3 different versions, but again, they don't want to sell them to you because they're too stupid to put up an ad that works. So anyway, I ran across the fact you can get a board. Let's see how to get back to there. What's this look like? So you come back here, you can get this board, and it's got the if you look on the right there, that 8-pin IC there is probably that WS 2811 chip or whatever it's called. And then down at the bottom, there seems to be a switching converter that converts the incoming voltage, which I think that they say this runs on 12 volts. So it probably converts at 12 volts down to 5 volts. And then all these other parts on the board is like basically they're building their own current sources to run the 3 LEDs that are on the board. And if you start digging, it turns out you can find other, let me get this out of my way if I can. Yeah, moving over here. So we move on to another one here. And it turns out you can get big LEDs. So these have the, I think they're claiming these are 20 watt. Here, we'll check in a second. Let me get this come back. So it says you can get, again, it says 20 watts here, and somewhere it says 30 watts here. But they've got these little pictures down here. If you click on the different pictures, here's this is the one with the clear filter over the LED says it's a 20 watt, and the one with the red filter over says it's a 30 watt. So if we go and look at this one, see inside of that chip there, you can see that it's got 5 or 6 of those dark LEDs across there. So this is the one they're calling the 20 watt. So there's a bunch of LEDs in series, and then it's got, I think this has red, green, and blue. Let's go see what the title says. Yeah, it says red, green, and blue, and you either get a 20 watt chip or you get a 30 watt chip. And this one is, I says 2 pieces of 20 watt, and it's probably 2 pieces of the 30 watt. Again, you have to read through the stuff real carefully to see what you're getting. So basically at this point, you apparently get 2 of these for $37. So we'll just say at $40, that makes them about $20 a piece to get these 20 watt ones, which these are way more power than you need for most things. But anyway, that's something else that turns up. So again, it's got a driver board. And this particular one, by looking at the board, you can see that it has, let's see, gotta get a bigger, better picture. No, we're just gonna have worthless pictures. Anyway, if you look at the board there, the board seems to have 3 switching converters. So each color on the LED has its own built-in switching converter. And then down at the bottom, again, it's going to have one of the chips to decode the thing, and then some kind of magic to convert those back and forth to make that work. So that's the 20 watt ones seem to be about $20 a piece. And here's some that's like that first one we saw. It's not exactly the same board, but it works the same way. And these are 5 boards for $50. So these are $10 a piece if you wanted to buy these. So that's much better than $100 a piece. And again, I'm not going to go through this a lot. I'm just going to say, you know, I found these. I can post these. Now it shows a little phone there. I don't know if the phone actually talks to I think the thing is, see down the bottom, they show a phone, and then on the right, there's I think a controller that your phone talks to if you wanted to, you know, control the lights on your house. Now, probably if you go through it, somewhere it'll say, oh, this is not included. So you're probably just getting the 5 LED modules. But these are, again, you have to look at the description. And it says, this one's red, green, blue, and white. And then there's another one that says RGBW. I think that means warm white. And the one just says W means daylight. Because if you look down here, it'll say 3000 Kelvin or maybe 2700 Kelvin, or the 2. So you can get you can pick the color temperature you want. So down here it says, if we look at the little selection down here, it says then it says RGBW 3000 Kelvin, and this one says RGBW 6500 Kelvin. So these are a nice bright white, and these are more of a yellowish white. So again, by picking and choosing here, I think they're all the same price. Let's see. Yeah. So whether whichever color you get, there's still 5 for $50. So they're $10 a piece. And then just moving on here. And then this is something else interesting. These are basically you just drill a hole in something, and probably a 3/4 inch or 1 inch hole, and you put the thing through it and then clamp it down. Now, if you look at these, I think this is simply 3 of the small LEDs, or smaller. They may not be as small as the ones on the addressable strips, but they're certainly not like a 1 watt LED. But there's 3 of them. I assume they're in parallel. If you come down here, look at this picture, you'll see they've got them lit up, and each one, all 3 colors are the same in each one. So I assume you go out and say module number 1, set it to green, and all 3 LEDs will light up that green color, or set it to red and all 3 will light up that color. But I don't think these are necessarily high-powered LEDs. And they're, what do you get here for? You get 20 of these for $46. And see, you also have to be careful, because they'll say it's the 50/50 SMD. Well, 50/50 means it's 50 millimeters by 50 millimeters. It doesn't necessarily tell you, the power rating or the current, or the light intensity output, but you can kind of just, get an idea by looking at this stuff. And again, read this stuff really hard before you invest in it, because you don't know exactly what you're getting. So these are simply, it looks like this. So it's got the module, and it's got an input connector and output connector, so you can just daisy chain them together. But I think the whole module then is whatever color you tell it. You can't do them individually. And what was the next one I had here? So here's one that's basically the same thing, but it's got 6 LEDs. And again, I think all 6 of these are in parallel, because if you look at the back of the board, it just says 1 driver chip, but it's got 6 LEDs. So this theoretically will put out twice as much light as the 3 LED one. But again, they're not going to be the high power LEDs. So they're just showing it hooked on the house here. This is always confusing, because they show, oh, well, your whole house is lit up the same color, but here you can see they seem to have different colors turned on, and here it looks like they have different colors. So I think it is truly addressable, but you're going to address a actual module. And these particular ones come in a string. And if you look at it, it'll say there's 20. It says 20 pixels for $77. So again, you just have to compare all the stuff. And I don't think these are, going to be extremely bright ones. So, but I just thought it was cute, so I thought I'd mention that. And then here's the one that's got the 3 LEDs, and instead of being separate ones, they put these into a string. So you've got, again, I think there's 20 of these. Yeah, 20 pieces, and they're telling the diameter of it, and then somewhere the spacing is, I think, 10 centimeters. That's about 4 inches between, from this module here to this module over here, which I don't know if you can see my cursor, but anyway, the modules seem to be 4 inches apart, and there's 20 of them on the string. And then what's the next one here? So here's one that's this is one I wanted to complain about too. So this one says it's a RGBW, so it's got red, green, blue, and white. And again, we'd have to look to see if they're going to tell us which white it has. Whether it's a real white, or it's a bluish white, or just a plain white, or a yellowish white, or an orange white. But anyway, if you dig through there far enough, it might tell you that. And this one is $18 for a module, and this drives so it's red, green, blue, and white. And this one has a detached LED. And if you look at the LED up there, you can see. So here's the LED, and inside there you can see 3 red chips, 3 green chips, 3 blue chips, and then under this blob on the bottom, I assume that's the white one. That's some kind of a color filter over it. So anyway, it's got a detached LED that you can bolt that down to something, because being a high power LED, it's going to get hot. So ideally you want to bolt this down to a chunk of aluminum or something. So what else they tell us? It's addressable. They say 12 watts. So again, you have to be careful. They might call it 12 watts. They might call it 3 watts. Regardless of what it is. So it probably means these are 1 watt LEDs in here. So 3 of those in series will give you 3 watts of red. And then if you got red, green, blue, and white, then that adds up. So that adds up to 12 watts total. If you turn them all on, you're going to get 12 watts out of it. And each individual LED is a 1 watt LED, but they're in series. So that's going to give you 3 watts of red, 3 watts of green, and 3 watts of blue, and so forth. So that's just another option. So here's what annoys me. Look at this. Again, complaining about the Amazon listings. You look at this, it shows you this module here. It's got the module and a detached LED. You come down here and they show you a totally different board. And this board has, it's the same basic board with the 4 driver modules or 4 driver circuits on it. And this one's got the LED soldered directly to the board. And nowhere here do they tell you which one, if you ordered this, they don't tell you which one of those 2 you're going to get. And I've read this over again and again. So here's the board with the attached LED, and here's the board with the detached LED. And if you're ordering them, you want to be able. Ideally, if I order 3 of them, I expect them all to be the same. And if I order some in 2 months, I expect to get the same ones again. But they don't want to play the game and tell you what you're getting here. So again, you got to be careful of this stuff. But for $18, let's see, they tell us what the power is. Well, 12 watts. Okay, I guess we just went through all that. And it says it runs on 12 volts. Some will say 12 to 24, and some just like this one just says 12 volts. So I don't know if they're serious about them being 12 or if they're running 24 volts. So anyway, that's just yet another option that has popped up. And what was the next one I had here? So here's one that these are basically just like the one we were just looking at. And let's see, get a close up here. Oh, and then they can't do these the same either. So the only way to zoom in is come here. And sometimes they give you a little plus up here so I can zoom in on that, but I can't. So let me back up here. See if I can find where I can zoom in. So again, the way somebody's prepared this listing, it just doesn't work the same as everybody else's. So that gets to be real annoying. So anyway, let's go back and look at what's going on here. So it says these are 3 watt / 9 watt LED pixel modules. So that means, I assume that means if you go look at the chip, it's going to have 3 red LEDs and they're probably 1 watt LEDs. So that means you get 3 watts of red. And if you turn them all 3 on the same time, you're going to get 9 watts total, I think is what they're telling you there. And this one's just red, green, and blue. You don't have a white in there. But essentially, the board is laid out the same way. So it's got 3 power drivers. It's got the RGB LED soldered directly to the board. And then over here, what was the deal on this one? So this company also offers these. So that's what, three boards for $42. So again, if you depending on what brand you pick, and these are RGB, they're not RGBW, but you can just compare all the stuff back and forth. Because about the second or third we looked at, you could get 5 RGB for $50. So those would be $10 a piece. These are whatever 42 divided by 3 is. So again, you have to pick and choose on this. So this company's selling both this board with the very high power. They say 3/9 watts with the solder on the board, or you can get the one that's just a smaller board that's got the let's see, what does this one say? It still says 3 watt, 9 watt. So these are either 1 watt LED chips or 3 watt LED chips inside of this one. Again, it's confusing because they're selling more than one thing and they don't really want to tell us what's going on here. So you have to kind of guess at it. Down here, usually they have a big section. Right here, they're telling you a bunch of stuff. And under product details, they might tell you some more stuff. And then, here they even give you a nice little video, which we're not going to watch right now. But so I'll put all these links out and you can go through and look at it. So here's one that it turns out Adafruit makes one that's a high power LED pixel. And these are addressable. But it turns out, if you look at this hard enough, they don't seem to be compatible with a NeoPixel, the WS8211 format. I think they've got each one of these modules has a microcontroller on it. I think they just have a UART interface. So you basically do the same thing. You say, here's my 24-bit color, but you send it out as UART messages. And if you go look at it, being Adafruit, if you go look at it, they give you the schematics of this board. They tell you the part numbers, and they say, here's the microcontroller you use. They might even give you the code for the microcontroller. But the point is, these I think are fairly expensive. These are $15 a piece. So you get a the 1 watt, and they call it 3 watt chainable. So again, it's probably 1 watt LEDs inside of that to give you the total of 3 watts if they're all on. And the other thing is these I don't think have the heat sink. So if we go look at the pictures down here, if we look at the side of the board, it looks like it's just a stamped out piece of printed circuit board. Yeah, the other ones that are connected down to an aluminum plate, it will suck the heat up out of the LED and spread that out for you. And another thing that indicates they're not an aluminum plate, because they show you the back of the board, and it's got parts all over the board, so there's really no way to heat sink, get the heat out of that chip. So you run a problem there that the thing may overheat on you depending on what you're doing. And at $15 a piece, you can get those other ones. It's a much bigger board, but you can get those for $10 a piece if you want to get those, and they are on something that's probably a big heat sink. Let's go back and see if I can find one. This one right here. I'm guessing that whole board is like a aluminum plate. They probably won't show me the back here. And here's another thing to watch for. They keep talking about here's this controller to run the whole thing, but somewhere in fine print it's going to say, oh, this control. Oh, right there it says not included. So you don't get the power supply. I assume you don't get the controller or not any of that stuff. But they're saying you could hook that up if you wanted to. So anyway, back to my thing I was talking about here. If you look at these, I'm guessing that whole board is probably an aluminum plate, so that chip on there can dissipate throughout the whole thing, and that's much better than the plate is bigger than the smaller ones. Like I probably don't have any of those. It's not convenient, but you get the small, just the RGB LED on the little round plates, like Al's using, and I'm using those. Those are better than just being connected to a printed circuit board. So anyway, I just wanted to point out that I made the comment, boy, it'd be handy if you can just get high-powered LEDs that are addressable. And it turns out you can if you go dig through far enough, and make sure you don't buy the one for $100, because I'm sure they'll happily sell that to you and not question anything. It's like, oh, but it said right there it's that much. So I don't know if you have a lot of recourse if you foolishly bought this one and you didn't want to. So that, I guess, I'll put links to this stuff out in the description, so you can go look at these if you want to. But again, beware, you got to read all the fine print, and just because it says it in the title doesn't mean it's actually there. Just because they show you a picture doesn't necessarily mean, because here they're showing you 3 different types, but you can only buy the one type. So again, beware of all this stuff on Amazon. You don't know what you're getting. You have to read it really hard and then hope for the best. And maybe if you go read through the comments at the bottom, somebody may say, well, I bought this and expected to do one thing, but it doesn't. Or other people say it works great. Other people say it didn't work out of the box. So you have to analyze all that stuff. And so I guess that pretty much sums up the LED thing that I'd run across. Since I'd mentioned it one time, I just wanted to point out, yes, they are available. And if you really wanted to, you could track these down, and it may or may not be worth buying a module instead of trying to wire all this crap together. So, and say in my case where I wanted the 4 LEDs, one pointed out each direction. If I buy the ones that's 5 for $50, then that means 4 of those boards on a box or whatever, or on a block of wood. And for $40, I can get enough LEDs that will be directly addressable, and that may work out. Because let's see, it was this one. Yeah, if you get this deal where you get 5 of these for $50, and so they're $10 a piece, and assuming they work, you'd have to look at the voltage input. This one says 12 to 24 volts input. So if that's really true, then these would probably work out well. And this is also red, green, blue, and white, so you get the 4 colors on this board. So that may or may not meet whatever your requirements are. And maybe you don't want high power LEDs in the first place. Last night, an ambulance pulled up out front, and boy, those lights are bright on that thing. And I kept thinking, should I go out and put my face up against one? Because the firemen are just going to throw me to the ground and beat me to death if I'm screwing around with their truck. So I figured it's better to do that. And at Walmart, they always put their car out in front. they're illegally parked with their lights on, just to let everybody know that Walmart has a shitty store. But I really don't want to do that with the cops, because in Minneapolis they've got a habit of throwing people to the ground they never get up again. So I'd rather do it with the fire department. So, but I didn't go out. I just looked at it through the window. That damn, those things are bright. So that I think that's all I have to talk about for this week. So I'll just turn it over to somebody else now. Let me stop sharing here. Okay.
Go ahead, Al.
Okay. Between my Raspberry Pi, you're looking at my Miro board, which is probably due for some maintenance, but I've been spending time trying to figure
Actually,
out.
that doesn't look like your mirror board. What are we supposed to be seeing here?
Oh, maybe I've got the wrong screen shared.
If you go up to the top where it says the little green thing, it says Al Jones is sharing. If you click on that, it'll show you what's going out to the world. It'll have a little drop down box and show you. But we're just seeing a desktop, and it says Raspberry Pi Imager. And maybe this is on your Miro board, but it's not what I was expecting to see.
I've got two screens here, and I've got user error on selecting the right screen.
There, that looks like your Miro board.
So this is, still my Miro board, where consider it my attic of documentation, and that gives you the right frame of mind on how well I've structured it. But I've got the teensy or low-level control, and I've got the RPi, which is running something called my teensy serial bridge to try to take information on and off, or be the two-way communication flow for my teensy. And others might have this all figured out easily in their head. Since I'm not using micro ROS, I've been spending time trying to figure out, so exactly which messages am I going to send from the RPi to the teensy, and which messages am I going to send from the teensy to the RPi. And so I think I've got that working. I think I'm comfortable with that. I tested some code to send linear, fake command velocity kind of data down from the RPi at 20 hertz, and data up from the teensy simultaneously to the RPi. So that's been my, doing a little bit better job of documentation and getting this teensy serial bridge Python code running and working and passing data back and forth has been my success for the week. What I haven't done is, now I've got to go back to my previous teensy code, and at the moment these are the functions in my teensy code, and now I've got to incorporate what I've learned about how to pass the serial data into all of those. So that's physically where I'm at the moment, is trying to integrate my learnings into my new teensy code, which will handle my serial communication, and avoid me from having to figure out micro ROS. In the meantime, what I was going to show you on that other screen was my Raspberry Pi 5 died unexpectedly. I mean, completely unexpectedly. And, there was no, I always use the battery, so it's always connected to the same battery. Sometimes I have the battery charger plugged into it. Sometimes I don't. Most times I do. So anyway, the bottom line is the RPi died. I had to order a new RPi a couple days later. A couple days went by and it showed up. And in the Raspberry Pi imager, there is a bootloader that you can burn to a disk and test that out. And I did that, and everything pointed to the CPU is dead. And I got to that point because the LED that the right by the on-off switch, there's an LED, and I never paid much attention to it. But when it wasn't working, the LED has a particular flash code, and the interwebs was telling me, oh, that's a power problem. And so bottom line is the RPi died. I bought a new one. I thought it was going to be my SD card. It wasn't. It was the CPU. And now I'm back up and running and testing again. That's about where I'm at. Lickety split. 3 minutes. Over to you, Bob.
Okay. I replaced the RPi, and then last time Jeff was saying he would use some different switches. So once again, I'm tore the thing apart, and let's see if I can share some pictures of the progress. Screen, recording, screen broadcast. So now, so can you see my screen? No?
No, not yet.
Okay. Mhm. Try again. Screen. And doggone it.
Give it another go. Sure you can get there.
Share, hit screen. I get screen broadcast.
Go.
Okay, so now I should be able to.
Yeah, I'm not an Apple guy, but I think at this point previously you've pressed escape or something and you've gotten to your main menu.
Yeah.
Just drag your cursor. There you go. I think you just drag your cursor to the bottom of the screen and this pops up. So
Yeah. So you can't see that, right?
we can see your desktop.
Oh, okay. So now I'll go to pictures, and Jeff was saying he would do things different with the switches. So I scrounged around for old projects, and I found toggle switches there. So I cannibalized them, and then found some other scrap, and put in toggle switches instead of the light. Now these are double throw, double pole, so it's kind of a waste, but it works. And got them working. Everything.
How did you,
Go ahead.
did you drill those out? I mean, those are probably round, but you had some square holes. How did you get those square holes so nice and square?
Well, the plate comes pre-formatted with squares and diamonds. So I picked one of the holes and started with a small drill bit, and then worked up drill bits, stepped up to different diameters, up to a 1/2 inch. And there's lots of burrs, so I had to take a hammer and pound them down, and then wiggle the drill bit to clean them up.
Nice.
And then I put that double back carpet tape on the back, and I didn't have to heat the tape up. I just cinched it down real hard with a pair of pliers, and it seems to be holding pretty good.
But the square hole ones that you showed on the previous picture, those were already there?
This one. No, I had to cut those and file them and cut and file, and it was a pain in the neck.
Mm-hmm.
But it
Well, it
started
looks nice.
with drilling 4 holes for the corners. And then I forget how I squared them up.
You got some machining skills.
Well, they aren't. Well, the square on the left kind of is telltale. I think I used a saber saw, a real small one. And then just, yeah, I can see a trace mark there on the lower right of the corner.
While we're
Okay.
talking about that, something else you can get something called a nibbling tool.
Oh,
And
yeah.
you could drill a hole, you drill like a 1/4-inch hole, and you put this like square cutter head in it, and then you squeeze it just like you do pliers, and it just knocks off a little, cuts out a little rectangular chunk of aluminum, and you just work your way down the
Just
edge,
keep
and
nibbling along.
yeah, you just keep going until you get till it looks like a hole, and then you're done.
Yeah,
But
the other
on the right, it looked like that's what you did, because around the edge of the hole there, it's kind of marred up, and I thought, well, maybe that's what you used on that.
No, actually, it was a file. I used the saw to rough them out, and then used a file to square them up. But
yeah,
that was a pain in the neck. But anyway, I cannibalized the 3 toggle switches and put them in there. I had some parts left over from some previous stuff, bolted that down. And I kept remembering that one should always tie all the grounds together. So right in the middle is that lock nut. All the grounds from the batteries and boards are coming into that. And then the other thing I started looking at once I got the Pi up was looking at WebRTC, whether I could do that on the pad. And this is what I came up with on a search. It seems like this stuff is embedded with Safari, Chrome, and Firefox. So I think this week I'm going to look into that. And then also you can do it on a Pi, but you have to use something like Media Mix or Janus Gateway. So I've got some more research into doing that for the Pi. So that's about, I think that's about all I got.
I got that WebRTC to work a few weeks ago, and I forgot what I had to install on the RPi. If you run into problems, let me know.
Yeah.
See where I put my.
Yeah, and I think I'll be focusing on that this week and see if I can burn up another RPi.
Yeah, don't do that. Those damn things are expensive.
Yeah. So that's about it. Now to stop. How do I stop this thing? Oop. Stop share. Okay, there we go. Well, that's about where I'm at right now.
So if you look in the chat, I put a link out to an Amazon for a search for nibbling tools. So
Okay, good.
see what those look like.
Yeah.
They seem like a really good idea, but they're really hard on your hand when you start doing that. It takes a lot of force to just squeeze it, and sometimes I can't remember ever damaged my hand by doing that. I don't know if you get your hand stuck in it or what the thing is, but
You might-
they're really slick. If, at least for cutting aluminum, they are. I don't know if you can
Yeah.
use it on steel or not.
So it might give you carpal tunnel.
Yeah, it might.
Hmm.
And probably if you look on YouTube, somebody will show you how to use those, and
Oh, yeah.
you can decide if that's what, something you want to attack or not. I
Yeah.
said on the Amazon search, it brings up lots of other things too that, for cutting holes and stuff. So
Well, eventually I've got to make a more professional looking carriage instead of my hacked plywood and threaded bolts and stuff. But I want to get things going first. And then I'm sure once I get going, Jeff is going to say, well, maybe you might want to do this, or maybe you might want to do that.
well, you might.
So right now, and until things settle down, I'll stay with my scrap plywood and bolts and see what else I can break.
Yep.
That's all I got.
That's it for me.
Okay, I guess it's all for me too. So let me see if I can hit the right button here.